All right, I passed this problem out in class, but if you haven't tried it yet, you might want to pause the video and try it first and then watch me solve it. The fizz produced when an Alka Seltzer tablet is dissolved in water is due to the reaction between sodium bicarbonate and citric acid. In a certain experiment, 1 gram of sodium bicarbonate and 1 gram of citric acid are allowed to react. A, which is the limiting reactant? All right, to solve this, I'm going to go ahead and convert both of these reactants to moles. So 1 gram of sodium bicarbonate, I'm just going to put SB instead of writing that out every time. And the molar mass of sodium bicarbonate is 84 grams per 1 mole. And then 1 gram of citric acid. And citric acid has a molar mass of 192.1 grams per mole. Alright, so that is 0.0119 moles of sodium bicarbonate and 0.00521 moles of citric acid. All right, so to figure out which one of these is the limiting reactant, I am just going to choose one and figure out if all of it was used up in the reaction, how much of the other reactant would be needed. So I think I'll start with this one, with the citric acid, for no particular reason. So 0.00521 moles of citric acid. Well, looking at the balanced reaction, if, let's see, for every 1 mole of citric acid that reacts, we need 3 moles of sodium bicarbonate. So I need to figure out what 0.00521 times 3 is. This is how much of the sodium bicarbonate I would need. And it looks like I do not have that much. So we're going to run out of sodium bicarbonate first. And that tells us that sodium bicarbonate is the limiting reactant. Now, could I have done it the other way? Sure, it doesn't really matter which one you pick. So let me show you just like how I would figure out the limiting reactant using the amount of the other sodium bicarbonate reactant. So 0.0119, and then looking at the balanced equation, I know that for every 3 moles of sodium bicarbonate, I only need 1 mole of citric acid. So if I divide this number by 3, I'll figure out how much citric acid would be required. And that would be 0.00396, and yeah, I've got plenty of that, plenty of citric acid. So again, it doesn't matter, you have to feel comfortable with it, but you really only need to pick one reactant. Convert it to moles. We'll convert both of them to moles, pick one of the reactants, and then look at the mole ratio and figure out which one you'd run out of. Okay, B, how many grams of carbon dioxide form? So let's take the amount of sodium bicarbonate we have. Since it's our limiting reactant, we need to use the limiting reactant to determine everything else. All right, and the mole ratio, let's see, we've got 3 moles of sodium bicarbonate to every 3 moles. Like for every 3 moles of sodium bicarbonate that are used, we make 3 moles of carbon dioxide. But the question asked for grams. How many grams of carbon dioxide will be produced? And 1 mole of carbon dioxide has a mass of 44 grams. All right, moles of sodium bicarbonate, moles of carbon dioxide, and I get 0.524 grams of carbon dioxide. Sorry, I'm just realizing that I'm off the screen. Okay. That's 0.524 grams of carbon dioxide. All right, C. How many grams of the excess reactant remain after the limiting reactant is completely consumed? In order to figure out how much we have left over, we need to figure out how much is used. So let's take our limiting reactant, the sodium bicarbonate, and figure out how much of the citric acid we would use. For every 3 moles of sodium bicarbonate, we'll need 1 mole of citric acid. Alright, and that is 0.00397 moles of citric acid used. Okay, now that we know how many we're going to use up, let's go back to the original number of moles of citric acid that we started with and subtract the number of moles that are going to be used up. Got 0.00124 moles of citric acid, but it asked for how many grams of the excess reactant will remain. So we need to use the molar mass of citric acid to convert back to grams. Oh, whoops, wrong number. Citric acid is 192.1 grams per mole. All right, and I got 0.239 grams of citric acid remains.